Hi, everyone. I'm glad to see a lot of welcome customer and welcome gentlemen and ladies. I will share my experience of integrating Welcome in SDK with our online education platform, the Oriental Cloud Classroom. My name is Jingguo Yao. I'm from New Oriental Education and Technology Group. My department is the Internet Product and Technology Center of New Oriental. Okay, here is my agenda. First, I will introduce our product, the New Oriental Cloud Classroom. The code name is Roombox. It is an online education platform. Secondly, I will introduce the Whiteboard, which is the main component of the Roombox. Thirdly, I will talk about why we choose Ink SDK to integrate with our Whiteboard. Fourthly, I will talk about how we have done to do the integration between Welcome Ink SDK and our product Roombox. And finally, I will talk about some prospects about the cooperation between the Oriental Education Group and the Work in SDK team. Roombox is an interactive online live broadcast classroom. It's purpose to serve the online education activity for company. The whole company and its subsidiary of New Oriental all use our product to do the education online. During COVID-19, there are more than 1 million students attend the online courses on our platform. And the maximum online learning student number reached over 500,000. The left screenshot shows the main interface between the students and the teachers. They are doing some interaction in our system. And the right screenshot shows some media coverage about our product. You can see the CCTV also had an interview with our product general manager. Here is the system architecture. There are 4 layers. The bottom is S layer. Above that as a pass layer. Then we have two different layers and 2 different approaches to serve the end user. One approach is 2C. 2C means we facing the teachers and the students. And for the 2C part, we support all the platforms. For example, we have clients for Windows, Mac, Android, iOS, and we also support web platform. And for 2B means that our product is not only used by one company, it can be used for a lot of companies. For example, besides New Oriental Group, a lot of third-party companies also use our platform. And there are 2 choices for them to use our platform. One is use it as a SaaS product. They can just log in or command cancel, do some data import, and arrange some classes. Then the teachers and students can have a class in our platform. And the other approach is to do deep integration. In this situation, the third-party companies want to use their own systems and don't want to use our interface. So we provide SDK. So after some coding works, they will have the online education capability inside their system. And for the online education situations, we have support for a lot of class types. For example, we support one-to-one class, small classes, and 2 teacher classes. And we also support big classes. The big plus means there will be more than 10,000 people in one classroom. And during the teaching, there will be a lot of interactions between the teachers and the students, not just the teacher talking. The students also can draw something on the client. And we have the whole control of our platform. For example, for the real-time communication, besides Agoro engine, we also have developed our own RTC engine, which is also used online now. After introducing our product, the Cloud Classroom Room Box, let's talk about the main components of our product, which is the whiteboard. For online education, the main interaction between the teachers and the students, one is the audio and video. They talk to each other, they see each other. And the other is the whiteboard. The whiteboard has two main functionalities. First, the teacher need to show the courseware inside the whiteboard. And they also use the whiteboard as a real event. They do some handwriting at the whiteboard. Show some visual effects to the teacher. For example, the teacher can send some stars to the students. And for develop a whiteboard, there are a lot of technology approaches to do this. There are two main ways to do this. One is to use C++. The good thing about C++ is its performance. Its performance is good. But there will be other problems. For example, it's hard to development, it's hard to maintain. You need to develop the code for a lot of different platforms. Our choice is the web platform. Here, I list 3 reasons for our choice. First is the cross-platform capability. We can do one coding once, then we can use it in our main platform, for example, Windows Mac. And the development cycle is short. For example, we have one visual effects we need to development. If we use C++, maybe 2 weeks are needed. But if we're done with the web platform, just 2 days are enough. Secondly, the web platform has a lot of resources. For example, there are a lot of material libraries for charting, diagramming, and visualization. If we use C++, we need to do it ourselves to do a lot of low-level development from scratch. And the last thing is the performance. Nowadays, the performance for the JS are good enough. After many years of optimization of the web platforms, we think the JavaScript is good enough for the performance. If we found some bottlenecks that shortcomings of JavaScript can be overcome, we can use WebAssembly to do some native development. But until now, we have never used any WebAssemblies. The JavaScript have served us well. This slide shows the handwriting function of the whiteboard. With whiteboard, the teacher can do a freehand writing on the whiteboard. For example, on the left screenshot, the teacher had drawn some shape like a cloud. And we also support geometric drawing. For example, the teacher could draw a circle with the pen in the whiteboard. The circle is not perfect, but we recognize the pattern. We will show a perfect circle in vector data. And we also have some whiteboard gadgets to increase the interactiveness between the teacher and the student. For example, we can insert some pictures, and we have dice rolling, and we support some small blackboard. And the second main function of the whiteboard is to let the teacher show their courseware inside the whiteboard. Nowadays, we support PowerPoint, PDF, which are the main courseware tabs from the teacher. We also support some little H5 game engine, some little games. We also added some support for the full game engine, for example, Cox 2D. The left screen shows a little H game. And the right screen shows some online experiment simulation. This feature allows the students to do some experiment simulation. For example, they can do physics experiment. In this screenshot shows the teacher can do some electric circuit test to learn some concepts. After talking about the main functionalities of the whiteboard, let's talk about how we choose the underlevel technology to support it. The most important thing for the underlying SDK for whiteboard is the handwriting processing capability. We have invested a lot of alternatives. For example, we invested some open source libraries. We also have tried to develop the library by ourselves, but neither them satisfies well. They all have some shortcomings. They cannot satisfy our requirements. Here I list the main requirements for whiteboard. First, we need to ensure smooth handwriting. We cannot literally feel there are some freeze during their handwriting. Secondly, we need to faithfully express the strokes made by the teacher. We need to express the thickness of the strokes precisely. And we need to store the data or the wet data besides bitmap data, which is very important nowadays. If we save the stroke data or the bitmaps, afterwards we want to extract the text data from it, it'd be very hard. But if we save the stroke or wet data or some math equation, the post-processing will be very easy. Then we come across Welcome Ink SDK, and I do some evaluation. I found it satisfy all these requirements. Here is a screenshot. When I'm doing the evaluation of the Ink SDK, you can see the Ink SDK can render the strokes perfectly. The thickness are very precise. When I draw with Ink SDK, I feel I'm drawing on a real whiteboard. The difference is very good. And the Ink SDK supports two modes, the bitmap mode and the vector mode. So we chose Ink SDK to do the underlying SDK for the whiteboard. The Ink SDK has a lot of wonderful features and it serves us well. For our functions like hand drawing, strokes, rendering, it's very good. But there are also some problems during the integration. One is the support for the infinite canvas. For our whiteboard, we want the teacher has a feel that the area for their writing is infinite. Here the diagram shows the whole whiteboard. There is one, the whole area is very big, but only one area, one small area is visible to the teacher. The teacher do drawings on this part. And when the teacher doing handwriting and the visible part floating around on the whole picture, the whole area. And if we let the Welcome Ink SDK to save all the strokes as vector data and do the parsing to the rendering over again, there will be a problem. The teacher will feel a screen squeeze because the amount of data we fed to is is too big. So we need to do some things to fix this. And this situation is real. For example, take one shortcut writing example. There will be more than 40,000 strokes on one page. So the data is huge. We need a solution to fix this. After some investigation and cooperation with the working ICT team, we together work out this solution. We, instead of parsing and reading the stroke data over again, we save the rendering results, and we divide the whole area into chunks. When rendering the chunks, first, we just show the saved cache of the stroke data in bitmap. Only when the student do some drawing, we use the vector data to the rendering and parsing. Here is the detailed design of our solution. On the bottom, there is the infinite cover the area. You can the gray area is the visible area. The teacher is actually working on it, and the blue chunks are the area that intersects with the line the teacher has just drawn. Above that is a visible window layer. There is a center point and a coordination system. And in the IndexedDB, we save the bitmap cache and vector data cache. And we also get the history. We get the history stores from our AM server, and then we saved in the IndexedDB. During the drawing, the strokes are rendered real time on the student test. The student will see the teacher are drawing a line, and when the teacher left the pen, the strokes will be re-rendered by the Ink SDK. So this approach allows us to handle a lot of strokes with high experience, and this approach has served us well. And we have also filed a patent for this design. And here is a screenshot of the whiteboard after we have integrated the Welcome Ink SDK. You can see the strokes are rendered perfectly. And inside our education group, the teachers love this product. They share their screenshots over their WeChat, and a lot of people come to our education group for class, and the whiteboard is a main feature of our online class. Besides using Roombox and Whiteboard inside our education group, nowadays we have also do some development to open it to the whole education industry on the Medcom website. If any education companies are interested in it, you can visit this website to have an introduction. Lastly, I will share my thoughts about the feature of the cooperation between Welcome Ink team and our team. First, we are thinking to convert the stroke into text. Because the strokes are served in vector data, it will be very easy to do it, and the Ink team has shown us this capability. Secondly, we want to do some filtering of the improper content in the handwriting. And third, we want to do some AI stuff to do some automatic problem judgment of the writing by the teachers and by the students. And we also want to support more devices to use our product. Now that we have support all types of Welcome products, and we have support also iPad, and we are planning to support more handwriting devices from other companies. Okay, that's all my presentation. Thank you everyone for listening. Bye-bye.